Hello, people, and welcome back to Michelle's version of calculus, where today we have 2.2 and we will be defining the derivative. Alrighty, let's just get to it. The derivative is an expression that calculates the instantaneous rate of change, aka slope, of the tangent line of a function. And this is basically the exact same thing we did in 2.1. As you can see over here, this right here, this box, are our expressions that it's talking about. We have the expression that was taught previously, f of x, or f prime x, which I'll get to in a little bit, equals limit of as h approaches 0 over all that nonsense. Or, of course, we have this version. Let me write this down before I lose it. Of course, the f of c would be used at a point. C is representing a value. And, of course, this one would be used for a whole function. I'll just represent like that function, which is why you have f of x. All right, so notations or ways you'll see the derivative shown. Of course, one of the first ways I have, let's do this in green, notations will be in green. One of the first ways we have is right here, f prime of x, which is the same thing as the derivative of f of x. You can also have y prime equals something. Let me write these all down. You have f prime x. And another way that you will see it is d to the y over d to the x, which is just another way of asking for the derivative of with the derivative of y with respect to x. Same thing as y prime f prime x and all that jazz. Yeah. And they have names, but that's not significant. As long as you know that if you see these notations, it wants the derivative. Alrighty. So we have an example here we're going to walk through, and we are going to be using, we're going to go ahead and use the top equation right here. We're using this one. Ooh, I'll highlight it for y'all. All right, so let us get into it. All right, so of course, as remember, this expression will help us find f prime x, or it will find the derivative. And once again, you will use the derivative, instantaneous rate of change, or the slope of the tangent line, to find the slope of the function at a point, at any given point, or yeah. Alrighty, so y equals 5x squared minus x. Let's get right into it. Oh, let's start with a different color. Start with blue. Alright, so first thing first, we're going to rewrite this whole thing. Lim as h approaches 0. Don't forget, please keep your limits on there. You will get points taken off if you don't. 5x plus h squared. All right, basically you're plugging in the x plus h here. The x plus h seen right here. And you're plugging it in for every value of x. So 5x plus h squared minus x plus h all over minus the original function, minus 5x squared minus x, and this is all over h. Alrighty. 2. Let's go ahead and pick a different color. 2. Alrighty, so now we're going to go ahead and we're going to open up this x plus h squared to make life a little bit easier for us. And of course, we're going to go ahead and distribute our negatives. Alrighty, let's go right ahead through that. So this will end up being 5 right here. It's going to be x squared plus 2hx plus h squared minus x minus h minus 5x squared plus x. Once again, this will all be over h. We're going to go ahead and distribute again further. We're going to put this 5 with all these other peoples. So 3, multiply the 5s. We have 5x squared plus 10hx plus 5h squared. Excuse me, minus x minus h minus 5x squared plus x, once again, all over h. And now we can get to the beautiful part of canceling out some things. So, of course, these 5x squareds, they will be canceled. Ooh, let me pick a better color than that. These 5x squareds will be canceled. These x's will cancel. And then you're going to be left with 4. You're going to be left with 10hx plus 5h squared. Don't be like me, guys. I did not keep my limit. Continuously going down, but we get the gist. 10hx plus 5h squared minus h all over h. And looky here, we can actually factor out each of these h's. Oof, let's pick a different highlighting color. We can actually factor out each of the h's right here. So I'm going to go ahead and factor those out. So we'll be left with h 10x plus 5 squared, or plus 5h, because you're just taking out 1, minus 1, all over h. And because of this, I don't think I've done green yet. Now, because of this, these two h's can cancel, and 5, you're going to be left with lim, as h approaches 0, of 10x plus 5h minus 1. We can go ahead and put in the 0 right here into n for h to evaluate this, and you are left with dy over dx, again, just one way of a different notation, or white prime, equals 10x minus 1. And basically, once again, you can use this derivative, 10x minus 1, you can plug in any value for x to get the slope at a given point. All right, last thing to kind of touch on is the equation of the tangent line. Nothing too crazy here, but equation of the tangent line is basically point slope form, which I'm hoping you'll know. Of course, we'll just highlight these. This is where you would plug in values. You would plug in the x or y, and of course, m forever and always is slope. All right, and that's how you get the equation of the tangent line. And usually with problems like this, they will give you the original point, they'll give you the point, and you might have to end up finding the slope by finding the derivative. And yeah, that is all. There were 2.2. Thank you.